Hey everybody in Math 910. I miss you guys so much and I hope you're all healthy and safe and making the best of this really crazy situation that we have. Welcome to our new classroom for the rest of the semester. I'm down in the basement of my house and it's gonna take some getting used to, I think, but I am just thankful that we have a way to continue our math lessons, even if it's not ideal. And I hope that you guys do really well, continue to do really well, even though we're not face-to-face anymore. As always, please do not hesitate to reach out and email me with any questions or concerns you have along the way. I'm going to try to make the rest of these lessons as smooth a transition as possible for you guys and try to make it as similar as our class was when we met face-to-face. All right, well, stay healthy, everybody, and like I said, don't hesitate to reach out. So here we go. All right, so I'm going to put my phone into this holder that I purchased on Amazon recently. I think this will work out pretty well. So let's see. Okay, there's that. All right, we've got our notebook here, and let me just center it a little bit better. There we go. Okay, great. All right, so the last time I saw you guys face-to-face, we finished lesson number 10, and in that lesson, we talked about how to multiply and divide fractions. We spent most of our time doing it by hand. You might remember our vocab word reciprocal. And that was a word that we used a lot because when we divided fractions, we actually had to change the division sign to multiplication and then flip that second fraction, or in other words, write that second fraction as a reciprocal. So that's the very last thing that we did when we were face-to-face. And then we spent a little bit of time also using our calculators, putting in the fractions that we were multiplying and dividing. Now the good news is, with the next exam we have coming up, exam number 2, we got through all the lessons that we needed to face-to-face that will be on that exam, with the exception of today's lesson. So this is the very last lesson that you guys need for that second exam. So hopefully you feel pretty prepared, and hopefully today's lesson also goes pretty well for you guys. Okay, so let's title this Lesson 11. And this comes from sections 4.4 and 4.5 from the ebook, if any of you are utilizing that. And so what we're going to talk about today then is how to add and subtract fractions. And this is probably the most difficult thing to do by hand. We will also talk briefly about how to use your calculator with this. That will save you a lot of time, but it is also important that you know how to do these by hand for a number of reasons. One of those major reasons is that sometimes you're going to see some variables in the problem. And if that happens, as you know, you can't really put variables in your calculator. You kind of have to know how to do that by hand anyway. So it's important that we know how to do it both ways. Certainly the calculator is a great way to check your answer, if nothing else. All right, so let's start off with a few vocab words like usual. And the first one that we're going to talk about is this phrase, like fractions. Okay, like fractions. Now we've never talked about these before because we never cared about them, but we care about them when we're adding and subtracting fractions. They become very important. And the definition, fortunately, is a very simple one. These are just fractions with the same denominator. Fractions with the same denominator. All right, and so here's an example. How about something like this? 3/8 and 5/8. All right, 3/8 and 5/8. Notice both of those fractions have the exact same denominator, the number 8. The numerators can be anything. We don't care what those are. As long as the denominators are the same, they are considered like fractions. All right, and so then the other vocab word that we're going to talk about for right now is, as you can probably guess, unlike fractions. Okay, unlike fractions, and these are exactly the opposite. These are fractions with different denominators. Fractions with different denominators. Okay, so again, it's all about the denominators. Notice there's nothing in the definition about numerators. And so an example of this would be something like this: 2/5, 2/5 and 3/4. Okay, notice those two fractions have different denominators. This one has a 5, this one has a 4, therefore they're considered unlike fractions. All right, so we're gonna learn how to add and subtract like fractions and unlike fractions today. And I will tell you that adding and subtracting like fractions is way easier. So we're gonna start with that because we need to know how to do that first before we can do the tougher unlike fractions. Okay, so let's write this down then. To add or subtract like fractions. All right, so to add or subtract like fractions, here's what we're gonna do. We're going to add or subtract, of course, depending on what symbol they give us, the numerators. Okay, you're gonna add or subtract the numerators. After you're done with that, the denominators, or I should say the denominator in your answer, stays the same. Stays the same, which is really nice. There's like no work to do there. And we have a little vocabulary for that. We call that called the common denominator. Common denominator. Hopefully you remember that phrase from a while ago. I'm sure you all learned it at some point. But yeah, we call that the common denominator when the denominator is the same. Okay, so now let's move on and do several examples together. And again, I'm going to try to give you at least one example of every type of problem that you will see in my math lab, and also that you might see on the upcoming exam number 2. So add or subtract and simplify when possible. All right, so we're gonna add or subtract and simplify when possible. That phrase, simplify, as you know, has come up so many times in this course, and it will continue to as we move forward. But that just means, as you might remember, that if you get to the end of your answer, but you can divide something out of the top and the bottom, then you need to do that. And now more than ever, that's very important because my math lab will not give you any partial credit for something that's not simplified fully. So make sure that you're simplifying all the way every time, because my math lab will only accept the simplified answer. So here we go. Example 1. We'll start off kind of easy like we usually do. So 5/11 plus 2/11. Okay, here's our first example. 5/11 plus 2/11. Okay, so again, if we follow what we just wrote up here, all you have to do is add or subtract the numerators, and then the denominator stays the same. So that's really nice. So usually we like to do the denominator first because it's easy. You just kind of write it down. It's like, well, if it was 11, then in your answer it's going to be 11. Notice these are like denominators. They are the same. So that means our answer will have that same denominator. So then on top, all you do is add the 5 plus the 2. 5 plus 2 is 7, and so you get 7/11. Now you have to ask yourself, can you simplify? Because again, if you can, you have to do that. Can you divide something out of a 7 and an 11 other than 1? And the answer here is no, you cannot. So that is your final answer, 7/11. Okay, great. And you could check these with a calculator to make sure, but yeah, we did a great job there. So, okay, -6/20. Let's make this example number 2 plus 1/20. -6/20 plus 1/20. So this one's just a little bit tougher because we have a negative in here now. But other than that, it's not that bad. So these are also called like fractions because notice the denominators are the exact same, 20 and 20. So that means in our answer, our denominator will be a 20. So we might as well put that down. And so now you just want to go ahead and add the numerators. You've got a -6 plus 1. -6 plus 1 is -5. And so you might be done, you might not. You need to ask yourself, can you divide something out of a 5 and a 20? And the answer is yes. The highest number you can divide out of a 5 and a 20 is a 5 here. So when we do that on top, negative 5 divided by 5 is negative 1. And then on the bottom, 20 divided by 5 is 4. And it's always, again, a good idea to ask yourself just one last time at the end, can I divide something else out? Because maybe I didn't divide by the highest number. So you say, okay, I've got a 1, I've got a 4. Can I divide anything out of those? And the answer is no. You're good. You are all the way simplified. And so your final answer is negative 1/4. Now also remember, guys, because it's been a while since I've seen you, this is the same thing. Negative 1/4 is the same thing as putting a negative in front of the fraction bar, right? You're also allowed to write it like that, negative 1/4, or if you really want, you could even put 1/-4. You might remember that. All three of those answers are the exact same. And if my math lab ever marked anything wrong that you put that was supposed to be like this, please shoot me an email and I will fix that immediately for you because all three of these are equal. Okay, let's move on to example 3. Example 3 of adding and subtracting like fractions. Okay, here we go. Example 3. All right, how about this one? Negative 5/24 plus, and I'll put this in parentheses, negative 7/24. Now, the only reason why I put that in parentheses is because it's a negative number and you have an addition sign before it. I'm not trying to trick you, but you might see something like that in my math lab, so I wanted to show it to you on our notes here. So again, we have like fractions. Notice the denominators are the same, 24 and 24. So that means my answer will have a denominator of 24, at least for now, because remember, we might be able to simplify. All right, so now we look at our numerators and we say, okay, negative 5 plus negative 7. Well, that is a negative 12, okay, when we add those together. And so here's the place where we have to ask ourselves, can we divide something out of a 12 and a 24? And the answer is yes. There's many things, right? We could take a 2, we could take a 3, we could take a 4, we could take a 6, and we could take a 12. And so, of course, you want to take the highest number possible so that you can save yourself time, so you don't have to keep dividing and dividing. So when we do that, we divide a 12. Negative 12 divided by 12 on top is a negative 1. And then on the bottom, 24 divided by 12 is 2. And so you end up with negative 1/2 or negative 1/2. And of course, there's nothing we can do to simplify that any further. That is completely simplified. Okay, good. The good news is, by the way, guys, if any of you have tried this already, as I've gone through these notes, if you put this in your calculator using the ABC key or whatever key your calculator requires you to use for putting in fractions, if you do that on your calculator, it will simplify it for you all the way, which is super cool. So when you put in this problem into your calculator, if you go negative 5 ABC 24 plus negative 7 ABC 24 and hit equals, it should give you negative 1/2. It should simplify it for you, which is really, really great. And that's going to be even greater when we get to the place where we're doing unlike fractions, because that's even harder. Okay, let's keep going. Here's where I'm going to start giving you guys some variables. And this is where using a calculator isn't necessarily the best thing because you have these x's. So what we've got is 2/9x plus 4/9x. All right, and so if we go ahead and add these together, well, the good news is they are like fractions, so we know the denominator will stay the same. But now on top, we just add 2 plus 4. It's pretty easy. You get a 6. And again, it looks like we're done, but is there a number you can divide out of a 6 and a 9? Well, yes, you can. You can divide a 3. That's the highest, right? Divide a 3. So on top, 6 divided by 3 is 2. 9x divided by 3 is 3x, right? The x is still there. Don't forget about them. And so now you have just a 2 and a 3 as far as the numbers are concerned, and there's nothing you can do to take out anything more. So your final answer is 2/3x. All right, example 5. Here we go. 5x over 18 minus 7x over 18. So this one looks kind of similar to the last example, but it's quite different. In the last example, we had a variable in the denominator, right? This time, our variable, our letter, is in the numerator. So it's going to give us a little different result. But notice, again, I'm giving you like fractions. These denominators are still the same. So that means 18 will be our denominator yet again for our answer. And then in the numerator, we've got 5x minus 7x. When we subtract those two, those are like terms, right? They both have x to the first power attached to them. So you've got 5x minus 7x. That's a negative 2x. Okay, good. And then you want to say, can I divide anything out of a 2 and an 18? And yes, you can. You can divide a 2 out. And so when we do that, on top, we have a negative 2x divided by 2. That gives us a negative 1x. Negative 1x is the same thing as negative x. And now that everything is My Math Lab based, it would be a really good time to get very used to that habit of dropping the 1 and making sure you just write negative x. So let's try to get into that habit so that My Math Lab doesn't mark anything wrong. And so then 18 divided by 2 is 9, and then you can't go any further. So your final answer there is negative x over 9. All right, example 6. This one might look crazy, but it's really not that bad. Here is a negative 7d over 15 plus 3d over 15 plus d over 15, and we'll end it there. All right, so I'm giving you now 3 different fractions that we're adding together, but the good news is, look at the denominators. All 3 of them have the same exact denominator. All 3 of these are like fractions. So that's really great news. So that means our answer will still have that same denominator as its denominator. So there you go. And now we're going to go ahead and add and subtract as necessary the numerators. So negative 7d plus 3d, okay, that's a negative 4d, plus d, that's the same thing as plus 1d, right? So we got negative 4d plus d plus 1d. So now we're at negative 3d. And so again, it looks like we're done, but we're not, because we can divide a 3 out of the top and bottom. And when we do that, negative 3d divided by 3 is a negative 1d. So remember, I'm not writing the 1, I'm just going to write negative d. That's the same thing as negative 1d. And then 15 divided by 3 is 5. And so my final answer is negative d over 5. Okay, so we're getting there. We're getting close to done with all of our like fractions, but I still want to give you guys a few more examples of every type of situation you could possibly see in the homework and on the exam. So it is important that we cover everything. So let's keep going just a little bit more. Negative 10 over 11 minus parentheses negative 6 11 and parentheses. Okay, so here we go. The reason why I'm giving you one of these is not just because you're going to see this in the homework, but it's great review, really, really good review, because we've had so many situations in our class where we have a minus minus, and sometimes we're allowed to make it a plus plus, and sometimes we're not. So let's very quickly review. When are we not allowed to make this into a plus plus? There's only 2 situations that we've learned that you're not allowed to. One situation is when you have absolute values. If this parenthesis here was an absolute value symbol instead, you would not be able to make this into a plus plus. The other situation is if there was some sort of exponent here. If this number was raised to a power other than 1, then we would not be able to make this a plus plus. But that's not our situation here. We do not have any absolute value, no exponents. So guess what? We can make that into a plus plus. So we are allowed to do that. So now our answer is going to have the same denominator as these. These are like fractions, so we're going to make that an 11. And now on top, what we have is a negative 10 plus 6. Negative 10 plus 6 is negative 4. And of course, you ask yourself, is there something you can take out of a 4 and an 11? And there's not. So this one is actually simplified all the way, so you're done with that one. All right, example 8. Example 8. How about this one? This is one of my favorites. I actually love these problems because they look nasty when you first look at it. It's like, oh great, this is going to be tough, you know, but actually it ends up being a pretty easy problem. Okay, so this one says 7a over 4 minus 3 over 4. So the first thing you want to look at is, are they like fractions? Yes, they are. They both have a 4 in the denominator. So again, I'm just going to put a 4 as my denominator for my answer. But here's the crazy thing about the numerators. This one's kind of a strange problem. You might even want to put a little star next to this one because it's such a different type of problem. The numerators are not like terms. This is the first time this has ever happened. These are not like terms. That means you cannot combine them. You can't add a 7a and a -3, or you can't subtract a 3 from a 7a. They're not like terms. So when that happens, I have great news for you. This problem is so easy. All you do is copy the numerators straight across like you see them, and that's your final answer. There's nothing more you can do. So in other words, you're just writing 7a minus 3. You're writing this whole chunk right here as your numerator in your answer. And that really is the final answer right there. It's 7a minus 3 over 4, and there's nothing more you can do. So those problems are actually nice. If you see a situation like that where the denominators are the same, but the numerators are not like terms, you can't combine them, then that should be like a red flag, a happy red flag that goes off where you're like, yay, I've got no work to do. And all you have to do is just copy the numerator straight across and copy the denominator. So it's pretty nice. All right, so there was that, example 8. All right, let's try example 9. Example 9, and let me just make sure I'm always centering my paper. Okay, there, yep. All right, example 9, here we go, example 9. This one is going to look exactly like the last one. I just wanna make sure you guys get one more example of it because it does come up. All right, so how about this one? Here we have 2x over 15 plus 7 over 15. And so they are like fractions, right? They have the same denominator. So that means my answer is going to have that same denominator. And notice the top, these are not like terms. You cannot combine a 2x and a regular old 7. Remember what we call regular old numbers? We call them constants. So you cannot combine a 2x, a term that has a variable and a constant. So again, what you're going to do is just bring it all down, 2x plus 7. And you're just gonna make that whole thing your numerator. So your final answer is 2x plus 7 over 15. So again, nice problem. I like those, nice and fast. And if you know what you're doing, nice and easy. All right, we're gonna do 2 more examples of like fractions, and then we'll do the second half of our lesson, which is what we do when we're adding and subtracting unlike fractions. All right, how about this one? This one says 3 over 16f minus 15 over 16f. All right, well, we've done one kind of similar to this a little bit ago. This has the same denominator right here and right here, 16f. So these are like fractions. So again, my answer will be 16f in the denominator. All right, so then on the numerator here, we've got constants, so we're allowed to go ahead and combine them. 3 minus 15 gives us a -12. And so if we look at these two numbers, we've got a 12, we've got a 16. What's the highest number we can divide out of a 12 and a 16? Well, the answer to that is a 4. You can take a 4 out. So -12 divided by 4 is -3. And then on the bottom, 16f divided by 4 is 4f. And so that's your final answer right there. -3 over 4f. All right, here's our last example that we'll do regarding like fractions. So I've got 9y over 8 plus 2y over 8 plus 5y over 8 minus 4y over 8. I don't know why I do that. I make my y's different sometimes. These first two y's look different than my second two. It kind of drives me crazy. Hopefully it doesn't confuse you guys. All right, so there we go. All right, so we have 4 different fractions that we're adding this time and subtracting. We're subtracting the last one, but that's okay. We can handle this because look at every single one of these denominators. So great. All of them are 8s. That means they are all like fractions, and that means that we can make our denominator and our answer the same thing, an 8. All right, so now let's go ahead and combine all of these numerators. We've got a 9y plus 2y, so that's 11y, plus 5y, that's 16y, minus 4y, that gives us 12y. Okay, so we get a 12y. And then, of course, is there something we can divide out of a 12 and an 8? The answer is yes, we can take a 4 out. That's the highest. And so if we do that, 12y divided by 4 is 3y over 8 divided by 4, which is 2. So your final answer is right there. Am I off the page? Let me see. I think you can see it. 3y over 2, final answer. Okay, great. So that is how to do, that is how to add and subtract like fractions. So I'm hoping you guys are feeling pretty good about that. I think what I'm gonna do, I wish I could see you guys right now. I would love to pause and say, hey, does anyone have any questions? So I guess we'll have to do our best over email. But what I am gonna do is stop this video, and I'm gonna actually chop this lesson into 2 parts so that this video isn't ridiculously long. So, all right, that first part was about 25 minutes. I'm gonna stop it right now.